Okay, so we're going to work with this problem. It's a problem from the textbook. You can look in the textbook more if you want to. I wouldn't let it concern you too much. It's a little vague with their answer and things like that. But I'm just going to show you how I would approach this problem. Okay, so it says graph the function. They give us an equation, kind of a different equation. They want us to graph it, and then they want us to estimate the local extrema, so the maxes and mins, and the intervals on which it's increasing. Okay, so the first thing is to get it to graph. You know, that's going to be tricky right there. X, f of x. So let's go ahead and do orange. I would go ahead and start with 0. Let's just start with 0 and -2 and -1, and we'll see what we get here. If I put in 0, it's undefined. So we know there's like an asymptote here. This is undefined there. Okay, what happens if we put in -1? Well, you're going to get like -2 minus 1/3, so -2 1/3, right? And if you put in -1, you're going to get -2, that should be a -1 there, sorry. -1 1/3, okay. And then if you put in -2, you're going to get, or -1, you're going to get -2 minus 2/3, so -2 and 2/3. Okay, let's just see what we have there. So -2, -1 1/3 is like maybe there, maybe a little lower, and -1 and -2 and 2/3, maybe like there. Okay. What do we think is happening between -1 and -2, I guess? So what's -1.5? Now, I put this in a calculator. Actually, I put in the positive case. It's going to be like -1.8. Okay? So if I go there, -1.8, it's going to be like around there or something. Okay. Let's put in -3 just for fun. So you get -2/3 minus 1. So that's -1 and 2/3, right? Yeah, if I put in -3, you have to think about it a little bit. -3, -1 and 2/3. Now we had a -1 and 2/3, didn't we already? It was 1 1/3, but so it's kind of doing this little thing like that. Like, you can look at it with a better picture. If you have a graphing calculator, you can put it in there too. Okay, let's continue on and go to the positive side then. If you put in 1, well, you're going to get 2 plus 1/3. If you put in 2, you're going to get, 2, you're going to get 1 and 2/3. Right? I want to make sure I'm doing this right. I put in 1 and I got 2 and 1/3. I'm putting in 2 and I got 1 and 2/3. And if I put in 3, I'm going to get 2/3 plus 1, so 1 and 2/3 again. All right. 2 and 1, 1 and 2 1/3. And a little higher than that, 1 and 2 2/3. And 3 is 1 and 2/3. And if you put in 2 1/2, you get like 1.6. Okay. 1.63 actually. So 2 1/2 is going to be a little bit lower here. So it's coming something like, something like this. These are really hard to read, and it should be symmetric, so something's off in my upper part, I think. I didn't do 2.5 is what I didn't do. -2.5. But that should be -1.63. So it's pretty close there. Okay. So something, kind of a very rough sketch. Okay. Like I said, you can go to what's called Desmos if you don't have a graphing calculator. It's free. You just Google it and you can type in it. It's really easy to use. You can type in the equation and it'll graph it for you. But I wouldn't spend a lot of time on this. But anyway, where are those local extrema? Well, somewhere in here, this is supposed to be up a little bit higher, I think. Right in there. Somewhere in here, there's going to be a local max. And then somewhere like down here, there's like a local min. And we really don't have a way to find it exactly in a graphing calculator. We do, but you have to have calculus. But with a graphing calculator, you can run a trace and get like an approximation on it. But like I said, I wouldn't spend a lot of time worrying about this. This video is kind of long. But we're just going to say, the local max is somewhere between -2 and -3. The local min is somewhere between 2 and 3. It occurs in that interval. So it's occurring somewhere in here, and it's occurring somewhere in here. Now, where is it increasing and decreasing? Or just increasing, right? Well, it's increasing here. So it's increasing from -infinity to about -2.5, I'm going to say. And then it's increasing also from this section here. So from 2.5 to about 2.5 to infinity. Okay. And that's going to be it for that problem.